In this video, we're going to look at gravity and mass versus weight. So first off, gravity, any two objects with mass will pull on each other with a gravitational force. So gravity is a force, or we model as a pull between any two objects with mass. So I will pull on the Earth will pull on me. We pull on each other through a gravitational force. The sun pulls on the Earth with a gravitational force, just like the Earth pulls on the sun with a gravitational force. And so we need to define a couple terms now. Mass is the measurement of the amount of matter in an object. We've already briefly discussed it, but it's just how much stuff is there, how much physical stuff exists in this object. Whereas weight is the measurement of the gravitational pull on an object. So something with more mass will also have more weight because it's pulled harder by the Earth. But they are different. One is the amount of stuff that's in the object. The other is how hard that object is pulled on with gravity. And near the surface of the Earth, weight is defined as Fg equals mass times the acceleration due to gravity. And we'll see why later. Don't worry about it for the moment. But for now, you can just know that this is the equation for it. The force due to gravity, the force of gravity on an object is equal to its mass times the acceleration due to gravity. That's also known as the weight. So if we want to compare these two, we can kind of construct a table here. So we'll have mass, we'll have weight, quantity, variable, units, and can it change? So quantity, mass is a scalar quantity. Weight is also a scalar quantity. It's the magnitude of the gravitational force. So even though it was defined, I kind of connected it to a force there earlier, it's just the magnitude of that. The variable we use for it, for mass, we use lowercase m. For weight, we typically will do Fg, or sometimes you'll see W. Less likely, it's mainly going to be Fg. And if you want to be really precise about it, you should put the bars around it so that you're indicating it's a magnitude. But if you just wrote Fg by itself, you would be pretty okay like that. The units for mass are kilograms. The units for weight are newtons or kilogram meters per second squared. And you can see that from the mg, the mass times the acceleration due to gravity. Can it change? Mass, you can change the mass by removing or adding to the object. So if you imagine like a ball of clay, I can change the mass by actually taking away clay or adding clay. That's the only way to change the mass. Weight, you can change it by moving closer / farther from the planet, or to move to a different planet. So if you went to the moon, your mass would not change, but your weight would. If you were orbiting the Earth, your mass doesn't change, but your weight does, ever so slightly. So that's kind of the four main things. So hopefully you can see the distinction here. As we work with it, it should also become clearer.